Today we are going to start chapter number 2, mathematics. Chapter number 2, mathematics, and that is having the title logarithm. Logarithm is basically, we will say, is a technique to show logarithmic function and exponential function to find the unknown variables over there and to manipulate for the complex or very large or very small quantities in very valid form over there. And this was the scale which was measured according to Al-Khwarizmi was a Muslim mathematician who introduced this technique over there. In chemistry, we used about this a pH for calculating negative logarithm of hydrogen ion concentration or like that. For the first one, before going towards logarithm, he is going to explain about scientific notation. Scientific notation over there. If I talk about scientific notation, I will simply say here like the very big quantities. For example, I'm writing here a big number like 2, 3, 4, 0, 0, 0, 4, 7, 8, 9, 7. It's not easy to summarize or make it an understandable form for it. So the method of technique is, as the decimal is not shown in this quantity, तो फिर हम यहाँ पे लास्ट में अपना डेसिमल कंसिडर करते हैं और इसको फर्स्ट स्टार्ट में फर्स्ट नॉन जीरो डिजिट के बाद प्लेस करें अगर, तो इसको हम कुछ इस तरह से लिखेंगे 2.34 मल्टीप्लाई 10 रेज टू पावर। जितने डिजिट्स आपने इस डेसिमल को बैक साइड मूव किया है उतने डिजिट्स आप काउंट कर लें, 1 2 3 4 5 6 7 8 9 and 10 digits you have moved it, so it will be 10 raised to power 10. So this is the reasonable way how to show a very large quantity up to 10 digits like that, or 11 digits notation over there. So if very smallest quantities like the size of a virus over there, I will also use the same technique like 0.1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm taking 4, 7 there. So now I'm moving it towards the right side over there. Then I'm counting my digits 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be written as 4.7 multiplied 10 raised to power minus 10 over there for this quantity to show in the form of scientific notation over there. So it's a technique to show the very smallest quantities and very largest quantities up to in the form of a standard notation, in which we can say our main number is first non-zero digit and then it is a multiple of the positive or negative power of 10 over there. Always remember, this power should not be in fraction over there. It should be in the form of digits over there. It should be in the form of integers over there. Let's go for the exercise. Exercise is 2.1. 2.1 exercise is going to explain about it. Then I will say here exercise 2.1 question number 1, having 6 parts according to this syllabus, where he is saying express question number 1, part number 1. He is saying to me, go to solve it. Okay, that is 2 with 2 to 4 to 6. 1, 2, 3, 4, 5, 6 zeros. So decimal is hidden over here when it is not shown. Then I will move this decimal up to this place. Then I will write it 2 multiplied 10 raised to power 6 over there. After that, part 2. Part 2 states that it is having 48900. 48900. Now the decimal is at the last and I will move it towards the first point. Then I will say it is 4.89 multiply 1, 2, 3, 4. 10 raised to power 4 over there. After that, part number 3 here, where he is saying to me that the value is 0.0042. Now I will have to move this decimal towards the right. Then you will have to move to the right hand over there. Then I will write it 4.2 multiply 10 raised to power 1, 2, 3 minus 3 over there. Always remember, when you move your decimal towards left, give power positive. When you are moving towards right, give power negative over there. After that, part 4, where he is saying that it is 0 point with 3 and 3, 6 zeros, 9. 0 0.1, 2, 3, 4, 5, 6 zeros, and then 9 over there. Then you can write it 9.0. 6 zeros already counted, and this is 7. 9.0 multiply 10 raised to power minus 7 should be written for this form over there. I will also say that we should go for changing of color here, because I think so I am little bit uncomfortable about this color match over there. Okay, part number 4. Then part number 5, here he is saying 7, 3, 7, 3 multiply 10 raised to power 3. Now I will have to move my decimal one digit back. So I will write it 7.3 multiply 10 raised to power 1 multiply 10 raised to power 3. In the previous chapter, you have learned that when bases are same, powers are added, then it will be 7.3 multiply 10 raised to power 4 over there. Let's go to part number 6 there, where he is saying 0.65 multiply 10 raised to power 2 there. All right. According to my rule, I will have to move one digit back. So it will be 6.5 multiply 10 raised to power minus 1 multiply 10 raised to power 2. Then I will write it 6.5 multiply 10 raised to power 1. Minus 1 plus 2 give us 1 over there. Okay, let's go to question number 2 there. And according to question number 2 here, wait a second little bit. According to question number 2 here, what I'm going to write here, question number 2 here, he is saying write it in ordinary form. Part number 1, he is saying write it in ordinary form. Ordinary form means 8.04 multiply 10 raised to power 2. It means I will have to move my digit 2 digits back. Then it will be 804 over there. Part number 2, here he is telling me to write 3 multiply 10 raised to power 5. So I will have to go with 3 with 5 zeros. 1, 2, 3, 4, 5. Like this, like this. After that, part number 3 is there, where he is writing about this 1.5 10 raised to power multiply 10 raised to power minus 2 there. So in this case, I will say I will have to to move my decimal point 2 digit back 0.015. So I have moved one digit this, I have introduced 1 0, then I place my decimal there. In part number 4, he is telling here 1.77 multiply 10 raised to power 7. So when I will write this number, two digits are already present when I am writing 177. 2 zeros are already gone, so 5 zeros more will be introduced. 1, 2, 3, 4, 5. So this is the way how to expand this. After that, he is saying here 5.5, part number 5, 5.5 multiply 10 raised to power minus 6. So for this one, I will have to move. One digit will be already considered when I will write it 5, 5. Then I will have 5 zeros with it. 1, 2, 3, 4, 5. I will place my decimal and place 0 as a complete digit over there. After that, part 6, he is saying here, he is saying 4 multiply 10 raised to power minus 5 there. So in that case, place 4 here. Your decimal is at the end of this 4. So move it back. 1, 2, 3, 4, 5. Place introduce 0 and this one. So this was your question number 2 there. Now I am going towards to write approximately question number 3, which he is stating over there. He is stating here the speed of light is approximately 3 multiplied 10 is power 8 meter per second. Express it in standard form. So speed of light is equal to 3 multiplied 10 raised to power 8 meter per second. And if I go to write the number in ordinary notation or in standard form, then I will say it should be written like 3 with 1, 2, 3, 4, 5, 6, 7, 8 zeros, then meter per second. This is the ordinary form of this question to be shown over there. So always try to focus the exercise questions and uh, don't worry about it, that how we should go and how should we introduce our pattern here. Wait a second, I will have to introduce a page here. Uh, Insert a page. Add no page, create a PDF, now file, now. Wait a second, no problem. I will add a new page here so that we can work more. Okay, I think so we have got this. Let's move to our topic. Okay, now let's move to question number 3 over there, where he is saying that after speed of light, in question number 4, he is saying the circumference of Earth is at the equator is 400,7500 meters. Okay, express the number in scientific notation. Okay, so he has given the circumference of Earth at equator. Circumference of Earth at equator. He has given this. He has given the value 40075, 40075 with tetra zero, with tri zero. 1, 2, 3 meters. Now he is saying express this number in scientific notation. So best way is decimal is here. I will have to move it after first non-zero digit 4.00, or I can write it by rounding it off this 7. I'm writing this as 1. 4.01 multiply 1, 2, 3, 4, 5, 6, 7. 10 raised to power 7. So this is question number 3 there. Now I'm moving towards question number 4 it was. Now let's move to question number 5 there. Question number 5 is giving us the diameter of Mars is 6 point this stands for 3 kilometer in standard form. Okay. Now he is saying diameter of Mars. Diameter of Mars. He has given the value 6.779 multiplied 10 raised to power 3 kilometer. If I want to write this in standard form notation, and then I will say here that it will be in standard form, he is saying. This is scientific form already given. 6.779, because 3 digit back, then kilometers. If you want to remove this prefixes also, then you can write it 6779 with 1, 2, 3 zeros with unit meter. So this is the prefixes which can be used and which can be relaxed. It's up to you. If you go for it, then it's fine. Then he is saying diameter of Earth in question number 6. He is talking about diameter of Earth. He has given the value that is 1.2756, 1.2756 multiply 10 raised to power 4 kilometers. Then we say it is have to move 4 digits forward. 1, 2, 3, 4. So it is 1, 2, 7, 5, 6. Then it is complete now, I think so. 1, 2, 3, 5, 6 kilometers. But if you want to write in about in meters, then it is 1, 2, 7, 5, 6 with 1, 2, 3 meters over there. So this is the way how to go for this exercise. It was exercise number 2.1, which we have completed right now. In the next class, we will go exactly towards logarithm, which is logs and arithmos, which means ratio or we can say proportion, ratio or proportion, which means logos and logarithm. So if I little bit give introduction to you about logarithm, then I will say it is made up of two words. One is logos, and after that it is going towards arithmos, most over there. So if I talk both about them, then it is related to ratio proportion. Ratio proportion. And John Napier also worked on it. Al-Khwarizmi also worked on it. And Scottish John Napier introduced about this. And how to show a logarithmic function as an exponential function and exponential function as logarithmic function. How to write that. It is easy way how to go for it. So I will say here, first of all, for example, a function is given as f of x is equal to, wait a second, color is not going to be chosen in a proper way. Wait a second, I should choose yellow. Let's try this. Yeah, it's fine now. F of x is equal to uh, f of x is equal to y. Like this is the function notation. This is called function notation, in which I will say x is input and y is output. For example, you are blowing air into balloon and the size of balloon is increasing. Input is air, output is increasing size. So this is the relation which is can be explained with the help of function. But when I show this function y in the form of x, like y is equal to a power x, this is called exponential function. If I want to convert it into logarithmic form, then I will say log, this is the power x, and this is the power y, like that. I will make y with log to the base a, this is the base of this power, and I will make equal to x. So this is called logarithmic function. Over there, always remember how to change the variables here should be keep in mind over there. For example, here he is saying like to prove the relation over there a little bit. I'm going to do just introduction about that. The solution will be in next class we will do, inshallah. For example, he is giving you log, I'm getting this example from the book over there. Log 8 to the base 2 is equal to 3. Then how can I write it? As to use this above notation, I will have to use this base as base over there. Front one is power and with the log is equal to. So y was 8, x was 3, and 2 power x, a power x is like that. So 2 power 3 according to the notation of 2 multiply 2 multiply 2 is equal to 8 over there. So this is the formation of notation. And for example, if you are given in the form of with the same base, like you are given log 10 to the base 10, then you will get value 1. For you are getting log to the base 3 to the base 3, then it will equal to 1. Remember this phenomenon over there. And mostly unknown variable will also be given. For example, I am taking some example over here. Log, I'm taking example log 25 to the base 5, I'm getting this equal to x, and I say to you, find x value. Now, what do you will do? You know, this 25 is just like a y, is equal to 5 power x. And if you make this 25 in index notation form, then it is 5 power 2, then it is 5 power x. So you can say 5 cancelled, you will get x equal to 2 there. So this is the way how to manipulate your functions related to logarithmic form. In the next video, kindly follow for the next exercise solution over there, and try to be focused. Kindly subscribe my channel, like the video, and share with your friends. Thank you so much. Allah Hafiz.